researchers! In this video, we are going to tell you about our research in the Indonesian Science Project Olympiad 2022. Assalamualaikum warahmatullahi wabarakatuh.
Based on the data from the International Diabetes Federation, in 2021, the number of people with diabetes mellitus in Indonesia increased by 10.5% and it reached 19.47 million people. In fact, 25% of diabetics have complications in the form of diabetic wounds, which can become an infection and can lead to amputation, even death.
Generally, people use gauze dressings and synthetic cotton in the treatment of diabetic wound. But these wound dressings have many disadvantages, such as not keeping moisture around the wound, containing povidone iodine which inhibits the growth of fibroblasts, and not being environmentally friendly.
Therefore, to overcome these problems, we as the young researchers create the innovation entitled Potential Hydrogel Patch from apple peel waste and rice husk using nanoparticle technology as anti-inflammatory and antiseptic for diabetic wound therapy. I am Anindita Rahayu and my friend Bylqhiz Ghanisah Bustomi. We are from MTSN 1 Malang City.
The objective of this research are, first, to find out the potential of manalagi apple peel waste and rice husk as a hydrogel patch for diabetic wound treatment through an in silico test.
Second, to find out the effect of manalagi apple peel extract nanoparticles and CMC from rice husk concentration on the characteristics and antibacterial properties of the hydrogel patch. And the last is to find out the best sample formulation of hydrogel patch.
We conduct this research in the science laboratory of MTSN 1 Malang City and the researcher's house from October 2021 to February 2022 with strict health protocols.
This research is an experimental method with an in silico, quantitative and qualitative approach. We made 10 samples variations with 3 repetitions for each sample to get valid data. This uses 2 factors, consist of nanoparticles chitosan ethanol extract of manalagi apple peel concentration and CMC rice husk concentration.
There are the tools and materials that we used in this study. The process making of hydrogel patch consists of several simple steps. First, the preparation of tools and materials, followed by the making of manalagi apple peel, extract nanoparticles, and extraction of CMC from rice husk waste.
The next stage is the making of hydrogel patch samples. First, we mix a hydrogel solution that consists of manalagi apple peel extract nanoparticles and CMC based on the concentration that has been set before with the addition of glycerol, chitosan, and calcium chloride, then mold and dried in the oven. After that, the hydrogel patch is ready to be tested and used.
And there are the results of our research. The prediction of active compounds interaction in manalagi apple peel waste extract against FGFR1 protein using molecular docking. It shows that HMF compounds are the strongest candidate for activating proteins and as anti-inflammatory agents.
Meanwhile, the prediction results as an antibacterial agent showed that pyrene is the compound with the most potential, because it has the strongest interaction in inactivating Pseudomonas aeruginosa and Staphylococcus aureus proteins based on binding affinity, RMSD, and hydrogen bond value. That is a 2D and 3D visualization of the predicted using computational simulations.
The prediction of toxicity and skin sensitization result, it is known that the compounds used in the making of patches didn't cause skin sensitivity and have a toxicity class which is safe to use for the skin.
The phytochemical screening test result shows that in the nanoparticles of chitosan ethanol extract of manalagi apple peels, only flavonoids and saponins were detected. This is due to the addition of chitosan and sodium tripolyphosphate as crosslinkers, which makes the protective active compound stronger.
The results of the hydrogel patches characteristic test on the thickness and weight parameters. A1C1 is the best sample with the lowest average value.
Furthermore, A1C1 sample was obtained as the best sample in the biodegradability test with the highest average degradation of about 84%.
Based on the water absorption test result, A3C3 is the best sample with the highest average percentage of 62%.
The water content test result shows that the A2C3 sample has the highest value with an average of about 78%.
The tensile strength An elongation test result shows that A3C2 is the best sample with the highest average value. The concentration of CMC2 high can cause solution in homogeneous patch and can reduce the value of tensile strength and elongation.
Based on antibacterial test results, A3C2 is the best sample with the highest average diameter of bacterial inhibition by 20 mm and can be categorized as having strong antibacterial activity. And the last is the organoleptic test result of our hydrogel patch samples.
Based on the overall results, A3C2 is the best sample which has the highest values for the parameters of tensile strength, elongation, acidity level, and antibacterial activity. Based on the following comparison table, the hydrogel patch in our study had better characteristics than 10 previous studies.
Our hydrogel patch has several advantages, including utilizing waste FO pills and rice hulls, its nanoparticle technology that can increase the effectiveness and stability.
Our hydrogel patches are easy to produce and apply, environmentally friendly and economical with an affordable price.
Based on those results and analysis, we got some conclusions, such as first, monolyg FO pill waste and rice hulls have antiseptic and anti-inflammatory properties based on the prediction results of in silico test, so that they have the potential to be hydrogel patches for diabetic wound treatment therapy.
Second, the concentration of monolyg apple pills, ethanol extract nanoparticles, and CMC rice hulls greatly affected the characteristics of the hydrogel patch. And the last, A3C2 sample is the best sample and the most suitable when applied to diabetic wound therapy as a substitute for chemical patches.
So, this is the last of our presentation. This is our documentation and references. Thank you so much for your kind attention, and we're sorry for our mistakes. Wassalamualaikum warahmatullahi wabarakatuh.